Hi guys, so this is a video trying to explain how to perform delta star and star delta conversions. Now we have direct formulas for these, and if you remember those formulas, it's very easy to you just put the values and you'll get the equivalent resistance in delta or star. But me personally, I forget those formulas very often, so then I came up with a very simple step-by-step process which you can follow, which will help you in case you forget the formulas. It will help you to develop an intuition as to what the formula would be. It will help you remember the formulas easily. So let's look at the process in which we can identify how to go from delta to star and star to delta, and what should be the value of equivalent resistances. So the very first thing which I like to do is to identify whether we are going from a resistance heavy side to a resistance deficit side, or to a resistance deficit side to a heavy side. What do I mean is, you just remember that delta is actually a resistance heavy configuration. So delta is a resistance heavy configuration and star is a resistance deficit configuration. So for example, we all know that if we have two resistances connected in parallel, their equivalent parallel resistance would be R by 2. So we'll go from a resistance heavy sort of a configuration to a resistance low configuration. In a similar fashion, analogous to this, if you have three resistances in delta and they have a value of resistance as R, their equivalent star configuration has each resistance value equal to R by 3. So the very first thing which you need to remember is identify whether R conversion increases each resistance value or decreases. So if you are going from delta to star, your resistance is going to decrease. If you are going to go from star to delta, resistance is going to increase because delta is the resistance heavy side. So the keyword is delta resistance heavy. Remember this. Then you find out whether our final values will be less than the initial values or more than the initial values. Okay, this is the step number 1. Now step number 2 is, let's say I have a configuration, any configuration 1 which is given to me, and I'm trying to find the value of resistances in the second configuration. So I can represent that the equivalent resistance in the second one is going to be initial resistance multiplied by some factor, let's say k. Now what we need to analyze in step number 2 is whether the value of this factor which I have is less than 1 or greater than 1. So from our initial judgment, if we are going from delta to star, we are going from a configuration which had high resistance to a configuration with low resistance. So in that case, the value of my multiplying factor is going to be less than 1. Similarly, if I am going from star to delta, my values of my resistance is going to increase. So this factor becomes greater than 1. So this is the second step. First step is identify whether we are going from low to high or high to low. Based on that, you make a judgment on whether this multiplying factor is less than 1 or greater than 1. Step number 3. Try to visualize this factor as a fraction. So this k is a fraction with some numerator and denominator. Now if I have a case where k is less than 1, that is delta to star conversion, obviously my denominator is going to be greater than my numerator. Similarly, if I am going from star to delta, my multiplying factor now is greater than 1, that is my resistance is going to increase. So my numerator is greater than my denominator. Okay? So this is what we have so far. Let's assume that this is the next thing which you need to remember. The first thing which you need to remember is that delta is resistance heavy. The second memory point is this k is going to consist of two terms, one summation term and one singular term. Now this summation term is going to be large in magnitude, this singular term is going to be small in magnitude. So if you have a case where your k is less than 1, that is your denominator is greater than numerator, your k will be of the form singular term upon summation term, because the summation term is large. Similarly, if you have a case where your k is greater than 1, you'll have a case where your numerator is greater than the denominator, so your k will be of the form summation upon the singular term. So this is step number 3. You identify what is going to be the form of your term, whether it is going to be a singular term upon summation term or summation term upon singular term. So this is a very simple analysis which you can do in like less than a minute, and then now you know that whatever answer you have, which you need to write is going either to be of the form of a singular term or summation, or summation upon singular term. Now the next thing, till here the analysis is going to be the same. Now for step 4 and step 5, we need to analyze delta star and star delta separately. So let's assume the case where you are trying to convert a delta configuration to a star configuration, right? So this is a delta configuration which I have, which has resistances RA, RB, RC, and I'm trying to find the equivalent R1, R2, R3 star configuration. Summation term for the delta configuration, this is a delta configuration. If you look at it, it looks kind of like a series combination. It is not a series combination. It looks kind of like. So you can remember from this that the summation term is just sort of like the series sum of all the resistances. So the summation term is RA plus RB plus RC. And this summation term is fixed. So for delta to star configuration, this summation term is going to be fixed. This value will not change. Now let's come to the singular term. For singular term, it is dependent on which value of resistance you are trying to calculate. So it is dependent on the star resistance which you are trying to calculate. So if you're trying to find R1, your singular term is going to be the product of the delta resistances which are connected, the adjacent delta resistances connected to this R1. So singular term is RB, RC. Similarly for R3 you have RA, RB, and for R2 you have RA, RC. So these are the values of singular terms. Now from our initial judgment, we know that we are going from delta to star, we are going from high to low resistance, which means my K is going to be less than 1, right? And if it is of the form of numerator and denominator, I know my numerator is going to be less than my denominator. So my numerator is going to be a singular term and my denominator is going to be a summation term. So just put the value of these summation and singular terms and you'll get your answer. So this K is numerator by denominator, singular by summation. Singular depends on the value of the star resistance you're trying to calculate. Summation is fixed, RA plus RB plus RC. So if you're trying to calculate R1, let's say it's some K1, as we earlier found out, it's RB-RC. The singular term for R1 is RB-RC. So just RB-RC upon RA plus RB plus RC. Similarly for R2, RA-RC, RA plus RB plus RC, and then you have your R3. So you can remember this formula, right? But at times you tend to forget whether whether the numerator is going to be a summation or it is going to be a sum of products or whatever. So when you have this idea clear in your mind that how my K is supposed to look like, this makes it slightly easier for you. And from there, this idea that delta looks like a series combination, so the summation term is going to be this, and it is fixed. And then you can try to find out the singular terms, and very easily you are able to calculate the equivalent series resistances. Now, for the case of, let's say, series to delta conversions, if you are trying to go from a trying to go from a star to delta conversion, let's say you have R1, R2, R3 in series, and you are trying to go to a delta configuration of having equivalent resistances RA, RB, RC. For this, the summation term, see, it does not look like a series combination obviously. So the summation term here is the sum of individual products. So product of any two resistances, you take all the possible combinations R1, R2, R2, R3, R1, R3, and you take the sum of it. And the singular term now, as we earlier discussed, depends on which value of resistance you're trying to calculate. So if I'm trying to calculate RA, the singular term is going to be the value of the star resistance, which is opposite to this, so R1. For RB it is R2. For RC it is going to be R3. So these are the value of the equivalent singular terms for each delta resistance, right? Again, the final step is we are trying to go from star to delta. We are trying to go from low to high resistance. So my K factor is going to be greater than 1, and so if I take K as a fraction, my numerator is going to be greater than denominator. So my numerator must be a summation term and my denominator must be a singular term. So my K is of the form summation upon singular term. The summation term is going to be fixed for all the resistances which I am trying to calculate. So for RA, it's sum K1, the summation term is fixed. Singular term we earlier calculated, which is going to be the opposite resistance. Similarly for RB, summation upon R2. For RC, summation upon R3. Right? So this is how you can try to analyze the question, right? Whenever you are given a delta to star or star to delta conversion, you try to figure out what is going to be the form of the equation which I am trying to make. And once you arrive at the form, whether it is going to be summation upon a singular term or a singular upon a summation term, then by looking at the configuration which you are given, if you are giving a delta configuration, you can try to visualize it as a series connection, and then you can find out your equivalent summation term, and then you can, for each individual resistance, find out the singular term and then just calculate the value. So if you go through this process, it kind of makes it easier for you to approach this question in the examination hall, because there are so many concepts which you have in your mind that these small formulas often slip out. So instead of trying to cram those formulas, you can just try to make a systematic process which helps you understand, okay, what is going on. For me, this analogy of a fraction of going from a high to low or low to high resistance values, it actually helps me visualize what is going on, and it makes the conversion very easy, right? So you can actually follow this process and try this out with a few examples on your own. Just make a random delta configuration, put some random values, and then try to solve using this entire process, and then verify your answers, right? Thank you.